Hello, year 11 students, and welcome to A-Level Physics at Oaklands. This is Mr. Ugalde, and first of all, I'm happy that you are considering physics as an option for next year. And in this video, I will give you some information about the subject, physics, and also about the course. Good, so first of all, why choose physics? Then, when I think about the why did I choose physics when I was your age, actually, I had to do all subjects in A level, and then I chose physics as a degree, solid state physics. I will explain later what it is. And there are many reasons that can kind of make you choose physics because you can choose a lot of degrees. It's a well-respected subject, but the main reason why I choose it is because I like, because it's enjoyable, it's interesting, and it's fun. So if you think physics is fun, if you like it, if you find it interesting, that's the main reason I would say for you to choose it. Here you can see some images. They represent some areas of physics, like for example, space. You can see there like a circuit. You can see the parts of a plane, a bit related with engineering as well, that I will explain later that is quite related, the building, something about energy, something about medical physics, like X-rays, magnetic resonance imaging. You can see both there. You can see the bridge as well, will be related with the materials as well that will cover. You can see the coins there because sometimes you can relate physics with finance a lot, as well as you do with maths. You can see this big book there that says knowledge, because I think that physics is a core subject in the knowledge that the human being has. For example, if you think in some aliens in a different planet and you want to know how developed they are, how much knowledge they have, you will think in the technology that they have, how much they know about the outer space, and if they can move around, how do they get energy from. So a lot of these considerations are related to physics. So I consider physics like part of the core knowledge that we have. Good. Here you have some degrees that are really related with physics, like physics, engineering, medicine, mathematics, electronics. These ones are really related. But a good thing about physics is that you can keep all your options open, because any subject that you want to do as a degree, they will be really happy to know that you have done physics. If you have a good grade in physics, I don't think there is a chance that they tell you in the uni you should have chosen a different subject. They will be happy to know that you have a good grade in physics, because it shows that you are hardworking and that you have a good understanding, you are ready to work. So all of them will be really happy to know that you have done physics. It's a very well respected subject. Maybe, if not the best one of the best ones. And if you look at this, you can see mathematics. Mathematics is really related with physics. Actually, some of the content is shared, and we cover it in both. And I'm going to go through the content that we will cover and talk a bit about it, because as I said, I think that the main reason to study physics is because you find it interesting. So I'm going to tell you what we do in the course. First of all, what is physics? In the dictionary, you can see the study of matter, energy, and the interaction between them. I think it's a good definition. And it's also a lot about questions and answers. You can see there, physics is about asking fundamental questions and trying to answer them by observing and experimenting. We do a lot of experiments. We are going to see later. I'm going to talk a bit about that later. And also observations. We do a lot of observations. There's a lot of thinking. It's called theoretical physics, because physics, as you will see, has different areas that can be quite different from each other. Some questions that physicists might ask is, how will the universe end? You will see that there are different theories about that. That will be part of theoretical physics, because it's like making predictions, collecting evidence, putting maths into that and try to get conclusions. How does the sun keep on shining? This one you already know from year 11. It has to do with nuclear fusion. You have done it in physics. How can we protect the environment and provide energy? You can see some links here with biology, for example, about the environment, energy. What is matter actually made up of? This is what I did my degree about. It was called solid state physics. It's about how really small particles, even smaller than atoms or electrons, interact with each other to make matter and to give properties to matter. It will be a link with chemistry. Why do we only move forwards in time? That's a bit more difficult question. You can see that time doesn't go at the same speed under different conditions. This is something that you can get ready to learn about once you finish the course. It has to do with relativity. How does a computer work? Obviously, you are thinking in engineering. Maybe physics is the more related subject to engineering with maths. And if you want to know how a computer works, you need to know about electronics, you need to know about circuits, and then you need physics for that. If you think that these questions are fascinating, if you are interested in them, probably you like physics, and probably you will like the course. Good. Here you have a basic plan for the course. There are 6 modules. Module 1 and 2 are practical skills and foundations. These 2 modules are everywhere. And then module 3 and 4 we do in the first year, and module 5 and 6 you do in the second year. Later I will speak a bit about the exams. For the exams, first of all I will say how long they are, how many marks. You have 3 exams at the end of year 13. Modeling physics, 100 marks, 2 hours 15 minutes, and exploring physics. The first one contains 2 of the modules, plus module 1 and 2 that are everywhere. And the second one contains the other 2, plus module 1 and 2. And the third one is a bit more difficult, and it's a shorter exam. It's more difficult to get marks there, and it contains everything. Okay. Here you have the modeling physics 1, 2, 3, 5, and exploring physics 1, 2, 4, 6, and unified physics, everything. There you have the titles. We are going to go through the topics now. So, because I think the best way to know if you want to do the course or not is to know what are you going to study about. Apart from that, these 3 exams, there is something called practical endorsement, which means that you have to do some practicals, some experimental work, in order to get them to finish the course and to get to pass it. So in this one, it says that you have to complete 10 Q experiments each year. Actually, you have to do 12 practicals over the 2 years, and then you have to record everything in a lab book as evidence that you have done it. At the end of it, you need to have a really good practical endorsement book, so you can show that you have done the experiments. And there is no grade of that. For that, it's just pass or fail. I can tell you that last year, we had the OCR people coming, and instead of 12 experiments, we were doing over 20, which means we do more experiments. They were glad that we were doing that, and all the students passed as well. Obviously, attendance is important, because if you don't come, you don't do the experiment, and then you cannot tick that box. And the universities want you to have this, so that will be good. We do a lot of experiments, there's no problem with that. Good. I will go through the scheme of work one by one. Module 1, development of practical skills, is doing the practicals and then knowing how to maybe record data in a table, use the equipment, safety considerations. Module 2, foundation of physics, is what you have done in GCSE as rearranging equations, looking at graphs, has to do a bit with maths. And we will be doing it during the course. You already know a lot of it from year 11, but we are going to go a bit further with that. And then the content. forces and motion, then you do motion, you know, speed, acceleration, kinetic energy, Sulfat equations is similar to the one you have done, the one you did in year 11. Forces in action, same theory that you have covered in year 11, but instead of one dimension, we do everything. We can do things in 2 dimensions, so X and Y axis, but it's quite similar. Materials, you have done a bit in year 11, it's about spring constant, how stiff materials are, but a bit deeper. Newton's laws and momentum, you already did that as well, the 3 Newton's laws, we do it a bit, we study a bit more about that. So you have to have it really clear. And momentum, you remember the exercise about conservation of momentum, so we do it in 2 dimensions, but it's the same physics. And module 4, that we do in the first year as well, is about electricity. So you can see charge and current that you have covered already, energy, power, and resistance, using the equations basically. Electrical circuits, so the circuits will be a bit more difficult than they were, but the basics are the same. Waves, in this one, you will do a bit more because the content we covered in year 11 for waves was quite basic, so you have to go a bit further about that. And quantum physics, which is a new content, a new part of this new content that it has to do with the really, really small things and how these things behave differently from what you have covered, for example, in module 3. And the second one, I will put everything in one go. Sorry. Yeah, you have thermophysics, which is like a specific heat capacity, specific latent heat, pressure, circular motion. A new topic is about how to put maths to things that are moving in circular motion. Oscillations related with circular motion, for example, the pendulum, things that are going back and forth. Put mass to it and study it. Gravitational fields, you did like weight, mass, and gravity, but obviously we are going to go a bit deeper with that. For example, studying the force between 2 planets that are far away. How can we put maths to that? Astrophysics and cosmology, you have done something about the stars, planets. So we are going to do it deeper now, but it's basically the same thing. And module 6, capacitors is part of circuits. You need to know about capacitors to know how circuits work, related with engineering, for example. Electric fields, you draw the arrows around the magnet or around a charge, has to do with that, and put some maths on it. Electromagnetism, you remember a current carrying wire can have magnetic effects. So now we are going to do it, to study this in 3 dimensions. We already did in 3 dimensions in year 11, but it will get a bit more difficult. And also we'll do the motor effect and generator effect that you already know about. Number 4, nuclear and particle physics. Nuclear physics we did in P6. Particle physics is about things that are even smaller than electrons, smaller than protons, and it will be interesting. And medical imaging, we did ultrasound, we did X-rays, we did gamma rays. So we are going to study like 4 or 5 techniques and how this is related to physics. Good. Expectations. There are no easy courses at A level, so it means any subject that you choose, you will need to work a lot for that. But for physics, we can say that you definitely need to be hardworking. You need to be serious with the work, do the work weekly. You will have 2 teachers, Mr. Hanley and myself. We are always ready to help. For doubts, maybe you want to come after school, we will help you, but you need to be responsible of your work and you need to work a lot. I said a lot of good things about physics because it's a really good subject, but you definitely need to work. It says there, hard work. We have 6 hours of contact time a week. So for each course, year 13 or year 12, you will have 2 teachers and you will do 3 hours with one of them and 3 hours with the other one. So you can ask doubts to any of us, even if we do different topics, which will be a good thing because it means you have 2 people to help you with the subject. You will be expected to study an additional 6 hours a week. Obviously, it depends on you because I would say at least 6 hours a week. Maybe you need more. If you need more, you do more. And if you need help, we give you help. But at least you need to do 6 hours a week apart from contact time. And you will be assessed weekly through short exams and with larger end of topic tests. So we are going to keep a track of how well you are doing to make sure that you get ready for the final exam. Here you have an example of, I will come back to this later. Here you have an example of last year, year 12, year 13. You can see that every week we do exams we do percentages, but maybe the exam is 20 marks, 15 marks. And we keep a record of how well or bad you are doing to know if you need more help, if you need to work more to make sure you are doing everything. You will see there that we track it. Good. Coming back to this, yeah, this is just the basic overview, the 3 exams that you can see on the right, and how much of the final grade they are. So practical endorsement is only yes or no. Unified physics, exploring physics, and modeling physics, you can see how much weight do they have in the final grade. And the content overview, I already went through it. So you can, I think it's the best thing that you know what topics will you cover. Okay, so that was all. Remember that you can send us an email, either Mr. Ugalde or Mr. Hanley, in case you have further questions. And also we are going to start uploading some resources in the group we have in Google Classroom. You can write there as well if you want, in case you want to get ready for next year. Okay, so hopefully I will see you next year. Thank you for listening to me. And I'll see you next year.